Today we are discussing about some of the fundamental aspects of solids. We know that the solid is a rigid material. We know that the solid is a rigid material and the solid possesses a definite volume and definite shape. So we know that such kind of an idea. And the solid, the constituent particles are arranged in a fixed position. In solid, the constituent particles are arranged in a fixed manner or fixed positions. And also they oscillate its on mean position. The constituent particles are arranged in a fixed position and they oscillate its on mean positions. So in solid, in nature, the two types of the solid exist. One is the crystalline solid and another one is the amorphous solid. The two solids exist in nature. One is the crystalline solid and another one is the amorphous solid. One is the crystalline solid. One is crystalline solid. Another one is amorphous solid. Amorphous solid. What do you mean by crystalline solid? Crystalline solid means the consistent particles are arranged in a periodic manner. Consistent particles are arranged in a periodic manner. The consistent particles are arranged in a periodic manner or regular manner. For example, the consistent particles in a crystal, in the crystalline solids, it's a regular manner. But in the case of amorphous solid, the consistent particles are arranged in a regular manner. And another point of the crystalline solid, the crystalline solids is arranged in a as short range as well as long range. Arrangement. The constituent particles are arranged in a short range as well as the long range arrangement. But in the case of the amorphous solid, the constituent particles only possesses short range arrangement. The amorphous solid in such crystal is only possesses short range arrangement. At another point of view, the crystalline solid showing a sharp melting point. They are showing a sharp melting point. But in the case of the amorphous solid, it does not possesses sharp melting point. It does not possesses sharp melting point. There's another point of view. Crystalline solids are arranged in a regular geometrical fashion. For example, some crystalline solids are arranged in a cubical structure, some crystalline solid is arranged in a rhombic structure, some crystalline solid is possesses hexagonal structure, for example. Regular geometrical structure. But in the case of amorphous solid, they does not possesses a regular geometry. They do not possesses regular geometrical fashion or geometrical arrangement. Geometrical manner. There's another point of view. In the case of the crystalline solid, they have definite heat of fusion. Definite heat of fusions. They have definite heat of fusions. But in the case of the amorphous solid, it does not possesses a definite heat of fusion. A definite heat of fusion. Definite heat of fusion. That does not possesses a definite heat of fusion. A definite heat of fusions. They possesses a particular heat of fusions. As another point of view, in the case of the crystalline solid is showing a clean cleavage property. They're showing a clean cleavage property. They're showing a clean cleavage. They're showing a clean cleavage property. But in the case of amorphous solid, they does not possesses. So they does not possesses clean cleavage property. Clean cleavage property. What do you mean by clean cleavage property? Means when a crystalline material is cut by using a sharp-edged knife, so we get a two clean crystals, to get a two separate clean crystals. So that means the clean cleavage property. And very important point in the case of the crystalline solid is anisotropic in nature. Anisotropic mean when we measure some electrical properties, measure the electrical properties in some physical property, or some other conductivity, other aspects. We have to measure some physical properties in different directions in a crystalline material. So you get a different value. That is mean the anisotropic. What do you mean by anisotropic mean? Anisotropic mean the physical properties in the different direction to get a different value. That means anisotropic in nature. But in the case of the amorphous solid, this is isotropic in nature. Isotropic means the physical properties in measured in a different directions in the amorphous material to get a same value, a unique value. So such material is isotropic in nature. This is very, very important. This is anisotropic. This is examination point of view, or theory point of view, or competitive examination point of view. This is very, very important. As another very, very important point, in the case of the crystalline solid or amorphous solid, crystalline solid is known as true solid. True solid. But in the case of the amorphous solid is also known as pseudo solid or super cooled liquid. Supercooled liquid. It's also known as super cooled liquid. Supercooled liquid. Example of the crystalline solid is sodium chloride, lithium chloride, and the zinc sulfide. We know that the sodium chloride is a rock salt type structure. We know that is some kind of an idea. And also in the case of the amorphous solid, this is the polymer, and another is rubber material, is also known as amorphous solids. The amorphous silicon is used as a photovoltaic material. What do you mean by photovoltaic material? Photovoltaic material means the sunlight energy, this is the sunlight energy, is converted into electricity or electrical energy. It's known as the photovoltaic material. Amorphous silicon is used as a photovoltaic material. A lot of application is amorphous solids, and the crystalline solid is also a lot of applications in nature. So in the case of the classifications of the crystalline solid and amorphous solid, the concept of amorphous and the the concept of isotropic and anisotropic is very, very important. The concept of isotropic and anisotropic is very important, and the amorphous solid is also known as the pseudo solid or super cooled liquid. The concept is very important, and also In the case of the crystalline solid is a true solid. An example of the crystalline solid and amorphous solid is very, very important for in the case of the competitive examination or theory examination point of view. So thank you to all.